about the ratings of silicon control rectifier or thyristor. So as we discussed, the voltage is maximum across the SCR when it is in offset or in reverse bias, whereas current flowing through SCR will be maximum when it is in on state. So while considering the rating of thyristor, the two states are taken into consideration, that is nothing but offset and reverse bias, whereas while considering the current rating of thyristor, the on state is taken into consideration. That's why I can divide the different current ratings which should be taken into consideration while working with any of the SCR that should be taken into consideration are average on-state current, that is called as an IT average, then average root mean square current, that is IT RMS, then IT SM is nothing but the non-repetitive surge current which is to be taken into consideration for the abnormalities in the device, and the next one is the I square T rating, then DI by DT rating, the holding current, the latching current, and last one is the IG, that is IG minimum and IG maximum. So let us see one by one. So first one is the average on-state current. So average on-state current results into different firing angles. Means average current which is permitted for particular firing angle is not constant for all the firing angles. Means as alpha changes, that is firing angle of an SCR changes, the average current is also changing. This is because if the same IT average is permitted for all the firing angle, then with a smaller firing angle, to get the same average current, it is required that the peak value of current will increase to a particular level which is exceeding the limit, because the power dissipation will increase, and as power dissipation increases, the heat which is generated at the junction will increase, and this heat may create a local hotspot across the junction and which will damage the device. So always you have to take into consideration that the power dissipated is not going to increase beyond a specific limit, and that's the reason that average IT current or IT average is specified at its firing angle, and it is different for different firing angles. Means as firing angle keep on increasing, the IT average keeps on decreasing. That is inverse relation between IT average and the firing angle. Next one is the IT RMS. In case of DC current, the average value and RMS value are same, but in case of AC, this may vary. Especially IT RMS taken into consideration in the cases in which the signals are of low duty cycle and higher peaks. Means nothing but in case of low duty cycle signals, so on time is very small as compared to that of off time, and if we take an average value, the average value may be very smaller than that of the maximum value required. But as it's a low duty cycle, even for a short duration of time, if it exceeds to a particular value, the device will get damaged. So in such a cases, we have to go for IT RMS, not should be dependent on the IT average, because IT average may be small because it's the average taken over a particular time, on time and off time. But in case of low duty cycle high peak signals, though average is small, but for a shorter duration of time, the current may increase to a specified limit and which will damage. Means even for a small duration of time, if current exceeds to a particular limit, it may cause of more power dissipation, and which may become a cause of increasing junction and damage of the device. Then third rating, especially this is taken into consideration for the abnormalities in the circuit, such as short circuit or fault in the circuitries. Means if short circuit happens, then excessive current may flow across the SCR and which will damage the SCR. So this rating is always mentioned by a manufacturer that the surge current is nothing but it is a maximum amount of current which can be safely allowed to flow through SCR without damage of the device in abnormal conditions such as short circuit or faults in the circuitries. Next is the I square T rating. It is nothing but integration of current with respect to time. So this rating is typically taken into consideration to coordinate with a time switch. Means even those for a small duration, as I said, if current exceeds to a particular limit, which may cause to the damage of the device. So I square T ratings gives you an idea about what is a time for which the device may retain for a higher current. Means if time exceeds to that, then device may get damaged. So we have to arrange, we have to coordinate fuse such that the fuse will get blow up before this I square T timings. means nothing but we have to adjust, or we have to design our protection circuitry such that maybe fuse or maybe some other protection circuitry such that it will activate below the time which is mentioned by I2T rating. Then di by dt rating, as if current di by dt is nothing but it's a rate of change of current with respect to time. Now as di by dt increases, and if di by dt increases beyond a particular limit, and say if it exceeds to the electron velocity, means if di by dt is greater than the electron velocity, then it may create a hotspot, local hotspot across the junction, and because of heating of this local hotspot, this may damage the junction and this may damage the device. So again, care should be taken that the current rating or the current which is varying with respect to time must not exceed to a particular level, that is di by dt mentioned by the manufacturer. Then earlier only I had explained the holding current and latching current. So holding current is nothing but it's the current related to turn-off process, and this is nothing but a minimum amount of current which should flow through anode to cathode to keep the device in on state. If the current flowing through anode to cathode reduces below IH, the device will turn off. So by controlling this holding current, we can turn off the device. Holding current is responsible, or it is current which is taking part in the turn off process. Then latching current, as I told you, latching current is nothing but it's a minimum amount of current which is required to flow through anode to cathode to keep the device latched in on state even after removal of gate signal. So always latching current is greater than the holding current, and latching current is responsible for turn on process. Next is the gate current. As I said in case of voltage rating, that voltage applied across gate must not exceed to a particular value. Same is true for gate current also. So a sufficient amount of gate current, that is which should be greater than IG minimum, should be applied across the gate terminal to turn on the device. At the same time, we have to take care that it should not exceed to a particular gate current, that is IG maximum. So gate current which is applied must be in the range of IG minimum to IG maximum, and every manufacturer gives this all the ratings, and we have to see that our device will operate in the safe operating area and will not damage in any of the conditions. So while designing the circuitries by using all these power elements or power devices or components, we have to take care of all these ratings what are mentioned, that is voltage rating and current rating.